Hello, my name is Gabriel, and welcome to my final presentation for EMA 4003. Today I'll be talking about graphite and graphene and focusing a little bit more about their structure, difference in their properties, and applications in the industry. Uh, Moving on to our next slide. So what exactly is an allotrope? So to introduce the difference between graphite and graphene, it's interesting to understand what an allotrope is. And essentially, in simple terms, allotropes are different forms of an element that have different properties because of the difference in the arrangement of their atoms. So, for example, carbon can exist in multiple different forms, so have different allotropes, such as graphite, diamond, fullerene, and graphene. Most of us are usually familiar with graphite and diamond, but those two other allotropes are also super important, and today I'll be focusing more about graphite and graphene. Another example of allotropes are the allotropes of oxygen, where we have oxygen gas, O2, and ozone, which is O3. And I guess a lot of us are familiar with those two as well. So now talking a little bit more about graphite itself. So as you guys can see in those pictures here, graphite is made up of layers of carbon atoms. And they are arranged in a hexagonal pattern. So each carbon atom is bonded to three other neighboring carbon atoms, as you guys can see in the structures here. And the layers in graphite, they're held by van der Waals forces, meaning weak forces, which is an interesting part of the material that we're going to focus later on. But the layering of graphite and the weak forces that make these layers bond together give a lot of the properties that graphite presents. And again, just to emphasize this, it's very interesting to understand how the chemical structure of graphite will impact heavily the properties that it has. And as you guys will see, graphite is super similar to graphene, and understanding the subtle differences in their structure will make such a huge difference in understanding their properties. So I just wanted to emphasize the fact that graphite is made up of these carbon layers. Carbon atoms are bonded to themselves by covalent bonds, and the layers itself are bonded and held together by weak forces, and in this case, van der Waals forces. So now I explained most of this already. Moving on to the applications and properties of graphite, which for me is the most interesting part. So some of the applications that we have. First one, conductivity. Graphite is an excellent conductor of both heat and electricity, and this is mostly due to the unique layering of the crystal structure. As I mentioned before, the material is composed of multiple layers, and this is one of the reasons why graphite is such a good conductor of both heat and electricity, because it allows electrons and heat to easily move through the material. Another interesting property is the chemical stability. Graphite is chemically inert, well, meaning it doesn't react with any other chemicals, and which basically makes it super stable and very resistant to chemical reactions, which makes it very useful in the refractory industry. Another application for graphite will be for lubrication. Graphite has a super low coefficient of friction, and of course this makes it a good lubricant. And once again, this is due to the layering of the structure that we saw in graphite, which allows the layers to slide past each other, reducing friction. And once again, we see how the interesting structure that we showed in the previous slide about the layering of the graphite makes up for such unique and different material properties. And finally, our last one, which essentially talks about how graphite shows anisotropic properties, meaning that the material will exhibit different properties in different directions. And once again, this is due to the layering structure of the material, which is going to result in different bonding patterns and different strength in different directions, which essentially is the meaning of this property. Now, moving on to graphene. As you guys can see, the structure is pretty much the same as graphite. However, the main difference here is that graphene is considered a 2D structure. So in graphite, we had the layering of the carbon atoms arrangement. In this case, we only have one layer. So think of graphene as being a single layer of graphite. So it's a 2D material. Uh, the same structure here is valid. It's a hexagonal pattern, and each carbon is bonded to three neighboring carbon atoms. And all the rest, when it comes to the chemical structure, is the same as a single layer of graphite. However, what is interesting to note is that the chemical and physical properties do change a lot, and this is what we're going to focus more here. Uh, so first one, we want to talk about the mechanical strength, which is mostly due to the strong covalent bonds between the carbon atoms. Super interesting. Graphene has such a high mechanical strength, and because of that, it's used in industries such as aerospace, automotive industry. And interesting fact that I didn't know about it, and I ended up discovering after doing some research, is that graphene is actually 100 times stronger than steel when it comes to tensile strength, which basically makes such a good material that's going to be resistant to the deformation and damage. Hence, the applications of graphene in the aerospace and automotive industry. Chemical stability, similar to the reason why graphite was chemically stable. Graphene is chemically stable mostly because of the strong covalent bonds. However, the chemical stability in graphene gives rise to different properties and applications. And the main difference here is in the biochemical industry. And for me, a question that I thought of when studying this material was why not graphite is being used in the biochemical industry while graphene is, considering that they have such similar structures. And this is mostly because graphene is considered to be more biocompatible and less toxic when compared to graphite. And the other reason is the surface area and size, which allows graphene to be of essentially better efficiency when it comes to the drug delivery, biosensing, which all depends on surface area and size. And finally, transparency. Uh, the carbon bonds in graphene are super strong and they do not absorb the light in the visible range, which makes the material transparent. I thought this was super cool, but it's also important to note that while graphene itself is transparent, a lot of the materials we see out there are graphene based, and that means this can decrease the transparency. So a simple example would be graphene oxide, which has a much lower transparency due to the presence of oxygen there. So now just a quick look on what the industries for each one of these materials look like. We can see that graphene is estimated to reach 2.2 approximately billion of dollars by 2031, and graphite is estimated to reach $50.1 billion by 2031. And as you guys can see, both industries are such massive industries when it comes to the valuation itself. But as you guys can see, there's a big difference between graphite and graphene. And the reason why is that graphite is much more readily accessible. And because of the 2D nature of graphene, it's a lot harder to actually produce the material itself when compared to graphite, which explains one of the reasons why graphite has a bigger industry is simply because it has been exploited for longer than graphene has been. And with that, I conclude my presentation. I hope you guys enjoyed and learned some interesting facts about graphene, graphite, and understood how simple and small changes in the chemical structure, as simple as layering of the structure or not layering or having a 2D material, can heavily impact the chemical reactivity, conductivity, and mechanical strength, giving rise to huge variety of applications. I hope you guys enjoyed, and thank you.